Assume a normal distribution. Normal distribution means this normal curve. This is not in the homework problem. I pasted it here from your textbook because we're going to need that normal curve. Good thing, definitely put this on your notes for the next exam. Assume a normal curve, normal distribution, and that the average phone call in a certain town lasted 8 minutes. So there's some average phone call length, 8 minutes, with a standard deviation of 1 minute. What percentage of the calls lasted less than 6 minutes? So normal distribution is how things are normally distributed. It happens in all kinds of situations in life. That's why they call it normal. It's normal, the normal distribution. And that's why we give it that name. And so all kinds of things in the real world are normally distributed like this, which means they follow this curve pattern that statisticians have discovered. Okay, so let's take the average. The average is right here. This X bar, that means average. And the average, the middle, is the average phone call lasts 8 minutes. So the average phone call lasts 8 minutes in this town, in a certain town. The average phone call lasts 8 minutes. Okay? But they're not all exactly 8 minutes, really, clearly. There's some that are longer, some that are shorter. Some are way longer, some are a little longer, some are way shorter, some are a little shorter. How far are they off the middle typically? That's the standard deviation. Standard deviation means typical distance from the middle. That's what standard deviation means. Typical distance from the middle. Average distance from the middle. How far are they off the middle? Typically, on average. The standard amount that they deviate from the middle is 1 minute. So some are only 30 seconds longer than the average. Some are 10 minutes longer. But on average, they're about 1 minute off the middle. That's how spread out the data is. So that's what these lines are, standard deviation. So that means from line to line, you're always going up by whatever the standard deviation is. In this case, it's just a simple 1. So we're going up by 1, up by 1, up by 1, and then the other direction from the middle, going down by whatever the standard deviation is. Jump, jump. So if 8 is here, this is 9, add 1, 10, 11, go then subtract 1 the other way, 7, 6, 5. So in other words, if we know that the phone calls in this town are the length of them is normally distributed, which I'm sure is realistic, almost everything in life is normally distributed, and that the average phone call lasts 8 minutes with standard deviation, typical distance from the middle of 1, then we could put in the 8 right in the middle, add 1, add 1, add 1, subtract 1, subtract 1, subtract 1, and then these percentages would hold true. And what are they asking us for? What percentage of calls last less than 6 minutes? So where's 6 minutes? Here is the 6-minute line. Okay, so what percentage of phone calls lasts less than 6 minutes? That means in this region, which is the less than 6 minutes region. Well, you can see right here this percentage and this percentage are below the 6-minute line. So just add them up. 0.15, 2.35 comes out 2.50%. That means 2.5% of all phone calls will be less than 6 minutes in that town. You can know it that precisely. This is very useful for data management in today's economy where things are so information driven and people keep data on all of our buying habits and all that kind of stuff. This is very, very useful information. So 2.5% would be the answer. 2.5% of all phone calls must last less than 6 minutes. So this normal curve with these percentages, you want to have it on your notes for the exam. It answers the questions for us.